Hello everyone. Here is day 31 LeetCode May Challenge problem. Edit distance. So we can find the problem description in the link given below. The problem says that we are given two words, word 1 and word 2, and we need to find the minimum number of operations required to convert word 1 to word 2. The permitted operations are like insert a character, delete a character, and replace a character. So we look over here that we are given two words, horse and ROS, HORSE and ROS. So what we can do is that we can replace H with R, we can remove R, and we can remove E. So in that case we will have ROS, word 1 equals to word 2. So we need minimum number of 3 operations for this. Okay, let's see that how are we going to approach to our problem. I would be using dynamic programming approach, but let's discuss how it comes. Okay, so I have written the two, I have formed a matrix, and I have written like two words ROS and HORSE on two sides of the matrix. And now suppose that in first case, look at this case, both are empty strings. Okay, if both are empty string, you can see over here that we compare this with this. If both are empty string, in that case we need 0 edits. Is it clear? Okay, now if word 1 was empty string and word 2 was R, so to make word 1 equals to word 2, we would require one operation, that is insertion of R. Is it clear? Okay, similarly, if word 1 was an empty string and word 2 was R and O, then we require two deletion operations. Two insertion operations. Two insertion operations, R and O. And similarly, if word 1 was empty string and word 2 was ROS, in that case we require 3 insertion operations. It is clear, hopefully, over here. Now, if the word 1 was H and word 2 was empty string, so we require one operation, that is deletion of H. Similarly, we can look over here that if word 2 was word 1 was HO and word 2 was empty string, so we require two deletion operations. Okay, then here similarly 3 deletion operations, 4 deletion operations, and 5 deletion operations. Okay, now we come over here. Word 1 is H, word 2 is R. In that case, since they are not equal, so we need to look for the number of operations we need to convert H to R. So it's very easy if we do it manually. Like we will look, okay, we just need to replace H with R. So we will say that I require number of operation as 1. If we look at it more detail, then we need to look one step above, that if they both were empty strings, in that case we require no operation. So if now they have one character which is not equal, we need minimum of this 3 positions and plus 1. So we require one operation. Okay, let's look at it more. We will come across many instances, so it will make it more easier. Now word 1 is H and word 2 is R and O. In that case, we need to replace H with R and we need to insert O. So it means minimum of these three positions. Which one? This one, and this one plus 1. So minimum of this is 1 and plus 1 is 2. Now word 1 is H and word 2 is ROS. So in that case, we will say that we need three operations. First, we need to replace H with R and then we need to add O and S. So minimum of these three positions, this one and this one plus 1. So we can draw a conclusion something like this, that if word I minus 1 is not equals to word 2j minus 1, then in that case dpij is 1 plus minimum of the three position, ij minus 1, I minus 1 j position and I minus 1 j minus 1 position. Okay, fine. So moving ahead to the same. So now we can do it a little faster, that O is not equals to R. So minimum of the position plus 1, O is equals to O. Okay. So now here it's something that if O is equals to O, then we need to look one word before it, which was H and R. So did H and R required any edits? Yes, they required one edit. That if I want to make H equals to R, then one edit. And since this is equal, so no edits over here. So we just need to copy this number over here, because this position doesn't require any edit since O is equals to O. But we need to look a letter before this position. So that required one edit. So same number of edits over here. Okay. Now is O equals to S? No. So minimum plus 1. Is R equals to R? Yes. So the same transferred. Is R equals to O? No. Minimum plus 1. Is R equals to S? No. So minimum plus 1. Is S equals to R? No. Minimum plus 1. Is S equals to O? No. Minimum plus 1. Is S equals to S? Yes. The same number diagonally above. Let's check over here, like if you want, that we are having HORS and this word is ROS. So how many edits we require over here is, the question says that we require 2 edits. Now let's see, do we require 2 edits? Yes. First we will replace H with R. So 1 edit over here. Then we will do nothing with O and then we will delete R. So we will get same ROS over here. So yes, we require 2 edits. Okay. Now E is equals to R? No. So minimum plus 1. E equals to O? No. Minimum plus 1. E equals to S? No. Minimum plus 1. So this points out to the final answer that we require 3 edits to make HORSE same as ROS. Let's look that if word I minus 1 is equals to word 2 j minus 1, then we just need to copy the number in the DP matrix diagonally above, and otherwise, as we discussed, we need to perform this operation. Okay, let's look over the code. So code is very easy. I create a DP matrix and then I iterate. If I was 0, the first case, that is empty string, then we just copy j, and if j is 0, we just copy I over there. And if they are not equal, then the diagonally above element is copied, and otherwise this operation is performed. and we return the final, the last value of that DP array. So like I run the code and I get the expected answer. So dynamic programming approach is really very worthful in this case, and it helps to solve this problem in a very fluent and easy manner. Hope you liked the video. Do comment below the space complexity and the time complexity of this approach. And don't forget to like and subscribe. Thank you for watching.